Good morning, everybody, and welcome to our session this morning. 11 o'clock is still morning in most people's time frames. Reducing embodied carbon with natural stone. My name is Gregg, and I work with the Natural Stone Institute. I've been in the industry for about 20 years, but I've only worked directly for the Natural Stone Institute for about 4 years. And I decided to come on full time with them because I was so passionate about sustainability and about working our industry towards on a path that would give us the data sets to really tell the story of natural stone sustainability. And it requires some data to prove our points. We can't just tell a fluffy story. And so I think that we've really made a lot of progress in the past few years, and I've been just really excited and blessed to be a part of that. And I am joined today with a number of panelists. I'm going to let them introduce themselves here in just a minute. But first, what we're going to talk about today is how to reduce embodied carbon with natural stone. So we'll kind of set the groundwork for what is embodied carbon and then how we can use natural stone to lower it. So we'll get into a little bit of the technical side of it, the acronyms and the global warming potential and all of this. But we're just really excited to have you guys on this journey with us today. So here's my panelists with us today. Is this still on the description? Okay. So my panelists are Sylvie, Dustin, and Rob, and I'm going to let them introduce themselves so that I don't miss anything that's really important. But they were all very involved with this case study that we're going to explore today. Sylvie, if you can go first and tell us a little bit about who you are, the company that you work for, and really what's your role with the whole embodied carbon conversation.
Hello, my name is Sylvie Beaudoin. I've been working with Polycor Natural Stone for over 20 years now. I am an architectural sales manager, and I like to say that I am a passionate person of natural stone, and I meet architects, installers, and general contractors, and I want to share my passion of natural stone. And so therefore, using natural stone is a very green material, and I really push that when I meet with architects in the design community.
Thank you, Sylvie. Dustin, go ahead.
Yeah, my name is Dustin South. I'm with Picco Engineering. I'm a project manager with 20 years experience in natural stone cladding attachment. And, when it comes to embodied carbon, it really for us is a selling point for natural stone. Whenever we're asked to, compare materials, it really is, something that we push for the people that are conscious of the environment and sustainability. So that's, where it comes into play for us.
My name's Rob Barnes. I am president and CEO of D. Brown Incorporated. We're a almost 70-year-old family business in the stone installation aspect of things. We do horizontal, vertical surfaces, interior, exterior, hardscapes. And for us, this gives us just another added thing that we can do, when we're trying to sell natural over manufactured products.
Great. Thank you guys so much, and thanks for being here today. A couple of them came in just for this session, so let's be very thankful that we have them, and we're recording it for future use as well. So we're going to talk about number one, again, laying the groundwork for what is embodied carbon, then how natural stone can reduce the embodied carbon, and then we're really going to get into the nitty-gritty details of a specific project down in Dallas, Texas called the Freedom Place, and how each of our panelists were involved with the project and how we ultimately saved that project 85% of the embodied carbon that it was originally forecasted for. So really exciting stuff. I think I'm pushing the wrong forward button instead of back. Okay, so natural stone is a natural material. We aren't crushing it up and gluing it back together. We're taking the stone out of the earth without altering the natural fabric of the material and using that in our dimension, in the dimensional building. It is incredibly durable. It can last lifetimes without the need for replacement. There are endless opportunities to reuse it, to refinish it. We can even take post-consumer material and refabricate it into something completely new. And I think that's really a huge selling point with natural stone that a lot of people don't embrace enough. It also reduces the embodied carbon, and that's really what we're going to get into in great detail today. But I want to ask our panelists before we move on, if a client is coming in and they have any interest in sustainability at all, what are the questions that you're getting from them? Do they already see it as a green building material, or is it something that you sort of have to convince them of? Sylvie, do you want to go first?
Well, natural stone, I always like to mention, it's from the earth, it's natural. There's no other elements besides water that we use that is recycled. So we really want to push that with the design community. They don't think about using natural stone as much as we would like to. And so that's why I guess we're here today to enforce that and to push that into the community, to say, hey, use natural stone. You're not going to be worrying about the VOCs. You're not going to be worrying about the carbon emissions because you're using natural materials right from the get-go.
And Dustin, when people come to you and ask about stone, are they concerned about land impacts? What sort of questions are they asking you?
Well, when we get involved in a project, usually, the material is already chosen. However, if we were asked early in a project, how do we compare manufactured materials with natural stone? I mean, embodied carbon is, increasingly a selling point that we use. I mean, obviously the aesthetics of natural stone is a selling point, and just the longevity of it. But people are becoming more and more conscious, and things like LEED and other initiatives that owners and architects want to put into their projects are coming into play, and natural stone fits into all of that for sure.
And Rob, I think with you, it's more about the durability, right? How long is it going to last? And how do you explain, that value when they're making their decision based a lot on price?
Yeah, we get into this all the time, and it's usually a comparison between precast or cast stone to natural material. And I basically tell them, if you want to build a 100-year building, you'll never replace the natural stone. If you want to use cast stone or precast, specifically cast stone, you may replace it a couple of times. So you have to consider that life cycle, advantage as well. But the embodied carbon information is really providing us an additional thing that we can talk to the owners about. Not only is it, the longevity and the durability, but now it's longevity, durability, and environmental responsibility.
Absolutely. Thank you, guys. So I'm going to try to break it down as simply as we can. We developed these graphics a few years ago, and I think that they've really helped to illustrate the impacts of bringing natural stone to market versus the impacts of other materials. So natural stone is an easy 3-step process. We're extracting the stone from the ground, which actually requires a lot less energy and a lot less emissions than architects seem to imagine it to be. And we can prove that with our EPDs now. We can show them it is very low, and they're glad to see these quantified numbers because they didn't believe us when we just told the fluffy story. So then we transport the material to the producer. Very often, the production facility is within miles of the quarry. It is not always that way. So it is something to be mindful of, because there is sometimes where the transportation is longer than it needs to be. But very, very often, it's very short distance. And then we cut it into units. Okay, we're not crushing it, gluing it back together. We are cutting it to size. We do some finish work on the surface and sometimes on the edges, depending on the application. 3-step process. Now, let's compare it to other materials. One thing that we get a lot of questions about is the land impacts for natural stone. You're taking a raw material from the ground. It's not renewing itself quickly enough to be considered a naturally renewable material. But guess what? All these other materials are starting at the same place that we are. They're all extracting raw materials from the earth. Very often it's natural stone, it's limestone, it's silica-based products, but they all are starting at the same place that we are. So let's get over the land impacts part, okay? Then they take this material along with several other ingredients, remembering that natural stone has only one ingredient. So there's a lot more transportation that needs to happen, right? Yes, we have heavy product. We've got load sizes. It is definitely the largest part of natural stone's impact to the transportation, but we're only transporting one thing, right? But these other materials are having ingredients like dyes and polyester fibers and styrene, sometimes potentially harmful materials. There's often high heat involved in the manufacturing process, which produces harmful emissions. There's materials that are potentially toxic to human health. And it's all a part of this whole process, crushing up the stone, gluing it back together, when if we just use natural stone instead, it's this easy 3-step process and it's ready to go. So I think when architects specifically see these graphics side by side, I see a lot of light bulbs going off in people's head. They say, yeah, I get it now. I see what you mean. There's a lot of other steps. There's a lot of other ingredients involved. So if we put it side by side in a graph format, my eyes are not as good as they used to be. Every year they get a little bit worse, and I can't read those numbers on the screen. But you can see the red one is the cladding, so this is precast concrete, okay? And that is natural stone. Next to it in the blue, much lower embodied carbon, which is measured in the kilograms of CO2 equivalent, okay? And then the middle one is flooring. So this is comparing terrazzo to natural stone, much lower, significantly lower impact. And with engineered quartz, again in the red at the higher bar, and the lower one with natural stone at 46 kilograms of CO2 per square meter. Okay, so significantly lower, guys. I'm not going to spend too much time on this alphabet soup, but if someone is more interested in learning about this, I would be very happy to have a conversation. I love talking about this stuff, but basically you need a PCR, which is a product category rule, before you can create an LCA, which is a life cycle analysis, before you can create an EPD, which is an environmental product declaration, before you can understand what the GWP or global warming potential is of your product. Is it all over your heads here? That's a lot of letters. But I think that this will make it a little bit easier to understand. So 1 ton of embodied carbon, or CO2 equivalent, is approximately what would be emitted if a car, regular old car with gasoline, drives 6,000 miles. If you pooled that embodied carbon into a physical body, it would fill up a hot air balloon. And if you wanted to offset the impact of 1 ton of embodied carbon, you would need to plant 31 to 46 trees. So now we're going to get into, okay, we see that natural stone is a lower embodied carbon, global warming potential than these other materials, but how do we actually do the math to figure out the comparisons? So I'm going to ask Sylvie to talk to us about this very brief case study about countertops.
Yes, so we have a few case studies that Polycor Natural Stone, being a natural stone quarrier with over 80 quarries in North America and Europe, we have the resources, and we need to have these quantities and these qualifications to help the design community better understand the carbon emissions. So in this here, we have a case study on countertops in a hotel with over 300 countertops there, using natural stone versus engineered quartz. Thank you. It's a word that I don't use often. We use natural stone much more often, of course. And here we're comparing the CO2 emissions of one versus the other. And by using natural stone on these 300 countertops, we'll have a saving of 32.6 metric tons of CO2. And what does that mean? Like Sarah had a slide earlier. Well, it means that you'd be comparing it to 195,600 miles, or 32 hot air balloons, or 1,255 trees. So the savings in using natural stone has a really high impact versus that engineered quartz.
Now, similarly, we have another short case study showing how an architect would calculate a carbon reduction for a flooring project.
Yeah, so this is a museum project that has 13 meters squared of flooring, And, essentially the natural stone is about a third of the CO2 emissions as compared to the terrazzo. And so it just becomes a selling point to the overall project when you start stacking the variables of all the different products that can help them with their lead initiatives and what have you.
And one final one on cladding. Dustin, you want to share about this one?
Right, so this is an exterior cladding project, an aquatic center. And the comparison here is between natural stone and precast concrete. So you can see here 21 kilograms of CO2 versus 73.3 kilograms on precast. And if you multiply that out and compare those based on the cladding of 201 meters squared, you get 12.5 metric tons. And so converting that into the comparisons, that would be 75,000 miles of driving, 12 hot air balloons, or 481 trees.
And if you guys are interested in where I got these data points, come and see me afterwards. I've got them published on our website, but we tried to use industry-wide EPDs. If there wasn't an industry-wide EPD available, then we averaged at least 3 individual manufacturers to come up with an average of those. So why do we care about global warming potential? Who's the drivers here? What's the incentive for manufacturers to create these EPDs and analyze their environmental impacts? And the very first driver that we are kind of preparing ourselves for is federal regulations, right? There's Buy Clean initiatives in California, in Colorado, and in Washington right now. And what that does is it sets a maximum global warming potential for the products that are used in construction. And right now, their Buy Clean initiatives are only defining that maximum number for the top 4 impact categories, and that includes concrete, steel, is it insulation, I forget what there's, glass maybe, but they're the top 4 impact categories. Okay, stone is not a top impact category. It's always going to be a very low environmental impact, and so it's not being forced to create this data at this point. However, because these legislation is being introduced right now, we know that it's going to be coming at some point in the future, so we're trying to prepare ourselves by getting the documentation ready now. Sylvie, what do you hear from design teams as far as, I need this EPD so that we can, play the LCA game?
Yeah, well, the EPDs have been available for a couple years now already, which is a great thing for the natural stone industry. Mm-hmm. But more and more, every time I go to these architects' office and designers, you notice in their libraries, in their product libraries, that they require to have green materials in there. They actually label it, or they might not even accept green materials in their library anymore. So I see an evolution in that instance in the design community to add to your government regulations as well. So I sense that there's going to be a bigger change as the design community evolves into that.
And there's lots of green building schemes out there, right? Like LEED is the number one. They just introduced V5. It's out for public comment, so that we're really closely reviewing that, right, Brittany? To make sure that we've got natural stone properly represented in giving design teams rewards for using lower embodied carbon materials like natural stone. But consumers themselves, especially the younger generation, like they have a lot more concern for eco-friendly materials. And so it's really important for us to prepare ourselves for that. Now, sustainability is a tiny sliver on this pie chart here. What factors influence materials decisions when they're deciding what they're going to put on the building, what they're going to put in the building? Price is number one. We do this survey consistently. We do live webinars once a month, and this survey is a common one that we ask our attendees. And this is about approximately the breakdown of most of the audiences. But we've got price leading, aesthetic, what does it look like? Is it going to fit the design scheme? The performance, is it durable enough? The care and maintenance is got to be easy enough for the homeowner, the building owner. Is it available? Okay, I might want something that's just hard to find, or sustainability, it's really low. However, the next question that we ask in this series is, do you see this chart shifting in the next 5 to 10 years? What do you think, Sylvie?
Definitely. I think that sustainability will have a bigger role into this pie chart in the next few years. We understand the global warming effect for sure, but the government and the regulations will have to play a part in that in order for that sustainability pie chart to change. Pricing has always been and will always be part of that. We'll just have to adapt and we'll have to educate the communities and the design community as the longevity, right? Like we're going to be talking over the Freedom Place project. Price is sometimes right up front, but long-term savings are something that we have to consider overall.
Absolutely. Dustin, have you noticed more questions in the past 5 years? Do you think that it's increasing in?
I mean, I think so. I mean, I've heard of LEED and these kinds of initiatives, ever since I started in the industry. So it's been there, but more and more I'm hearing about, questions about, what is where is it manufactured and how far does it need to, travel to get to the site, and these kinds of considerations are becoming more and more a part of the conversation about, where not only what material to choose, but within natural stone, where is it quarried and how can it get to the site?
Mm-hmm. And Rob, you're preparing yourself because, right now it's kind of an evolution, right? We've got design teams that are concerned about it, and a lot of times, the price is a little bit higher, and so they cut it out, they don't consider it, and by the time it gets to you with installing it, they're not talking about sustainability anymore. But it's something that I think is going to be changing.
I think, just to give everybody a little bit of context, I'm in Dallas, Texas, and I've been in this business in and around it since I was 13 years old, almost 40 years now, full-time for 30. The Texas market's always been heavily driven by fossil fuels, but we've had such an increase in population, mainly coming from California, from a lot up in the Northeast, and people are becoming, because of the influx, a little bit more environmentally conscious. The Austin market, which is our capital, is become a very green environment, and they've actually passed laws now on the state or federal buildings that are built in Texas that are, I believe it's over 10,000 square feet, that are required to have some sort of LEED certification. So, it's becoming more of a conversation piece than it has in a long time, and I really believe over the next 5 years it'll be more commonplace than what it is now. There's still, price is always a huge factor, but we'll get into a little bit of that comparison here in a few minutes.
We sure will. All right, Sylvie. Polycor, was it a year ago, 2 years ago, put together this very extensive case study that allows us to really calculate and showcase natural stone's low embodied carbon. Why were you a part of that process? Did Polycor have a bunch of meetings to decide this is the project we're going to do?
The project itself lent great to that case study and to that, and we'll be talking about that project more in depth. But Polycor Natural Stone had the resources with regards to a sustainability team, and so we believe in order to advance the industry in the natural stone, we have to have hard numbers. We have to demonstrate and show the community and show the industry, hey, here are some facts, here are some EPDs, here are the HPDs, here are the numbers to prove that natural stone is there, even though in our hearts we know natural stone has always had the low embodied carbon, but we have to make our case. And we had the resources, and this project with the use of our quarries at the Indiana limestone quarries was a great opportunity with Rob here to demonstrate that in numbers, and we will see those numbers. And Rob has this quote, and I'll read that. Rob, I'll reread you. It has always been my opinion that cathedrals, governmental and institutional higher educational buildings, and museums should be statements built to last the test of time. These iconic buildings should be built with products that are proven natural and will stand the test of time. Let's just build it once, right? We always say build it once, build it with stone. And that brings us to the Freedom Place Oakland Park project in Dallas. And so his history in that project really lent, like I was saying, the opportunity for Polycor to get involved because of the use of the Indiana limestone material. And the story that Rob will be telling us gives us the cast stone versus the Indiana limestone was a great window for us to say, hey, let's dive into this and dig out some numbers, and we will see those.
That you did, and we appreciate the leadership there, Sylvie.
So-
Rob, do you want to talk about the project?
Yeah, so, this was a project that we were awarded in 2017 that we completed in October of 2019. Because of the longevity of our company and the footprint that we have in the marketplace, my impact goes, my goal is to work direct with owners, not just the architects and the contractors. And I actually ticked the contractor off when I did this one, but because they were going to build it out of cast stone. And it was designed out of cast stone, and we weren't part of the design development project aspect of this thing. And the cast stone in the marketplace was a little bit, in extremely high demand, so the price was going up. So that helped with that delta. But I also had a long-term relationship with the owner, and I trumped the architect and which was also the Beck Group. They have architect in-house and construction team. And with the use of Craig Hamilton out of London, who had a completely different mindset about things, he loved the idea. But we took this to the owner directly and presented doing it out of natural stone in lieu of cast stone. They were having challenges with some of the cast stone installations that were on other buildings on the campus. And really the easy sell was the original building was built in 1894 that's on this campus, and it was the old Parkland Hospital, which was the first county hospital in Dallas, Texas, and it was a nurse's headquarters, and it was built out of Indiana limestone. Well, we cleaned and restored that building, and it looked, just like it was built recently. And so when I went in, I said, it's a little bit more money for the limestone, but you'll never replace it. You see these guys out here on these other projects that have been built on this campus, and you've got cracking and crazing and manufacturing challenges that they have with trying to get profiles this big in a tamped cast stone product. So, I said, look, you want to build the President Bush 43 was going to be on the 6th floor of this building. It was very ornate, like I said, designed by a classical architect out of London. Honestly, it wasn't that hard of a sell when you say, look, you started here, let's finish here, because this was the last piece on the campus. And so it really turned out phenomenally well. And we worked heavily with Picco and on the engineering aspect because it was designed for cast stone, and so we had to make some modifications. But some of the things you can do with the natural stone that you can't do with cast products, you're not as limited by size. And so we had bigger pieces, we combined pieces, which actually helps a little bit with schedule as well. But and we were intense for about a year with these guys on the engineering side and them on the coring side. So it turned out, as a statement piece, not only for the campus but in the city.
Dustin, what was Picco's role?
So as Rob mentioned, D. Brown brought us on board to design and draft and engineer the attachment system for these large format stones, as well as to consult on the structural existing structure that was there and provide any modifications that may be needed. And as Rod mentioned, it's a very challenging project from the size of the pieces that were there, and trying to facilitate a way to attach them to an existing structure can be a challenge. But yeah, I mean, that's our specialty, and so it was something that we took on with great pride, and we're extremely happy with the results. It looks great.
When you say large pieces, how large is large?
Oh,
Some of them got up to, some of the door headers were about 14,000 pounds.
Yeah, and some of the cornices, 2 or 3 feet, projected, and very large corners. And when you have a piece like that on a corner, sometimes there's not a lot of structure in behind it.
Sure.
When it's sticking out this far and this far on the corners. So we had to develop these very thick plates and a lot of time and energy into the design, but it was worth it.
And Picco specializes in natural stone, in engineering cladding systems for natural stone. So how did that start? Do you know more of the history of why the specialty was chosen with natural stone?
I don't know the specifics of the history. Mike would be better to
Yeah.
answer that, but I know that he worked within natural stone industry before going out on his own, and he saw that as a niche market that he could get in and be a leader in, and so that's I think where that came from, and that's what we've done. I think we've really established ourselves as the leader in stone attachment and engineering.
Yeah, I absolutely have.
So one of the keys to being able to do stuff like this, like I said, is the architects are becoming more familiar and more concerned with the sustainability impacts. But when you can talk to the guy that's writing the check, that is a lot better sell. So and we just finished converting another project that we have gotten released to do. That's a cast stone product that was built the Southern Methodist University building, and the cast stone was installed in 1986. It's cracking, rebar's exposed, and I went in and they wanted me to replace the cast stone with cast stone, and I said, do you really want to do that? Because if we replace it with limestone, day one, you're going to spend a little bit more money, but you'll do it one time. And we won't be having this conversation, or the next generation won't be having this conversation 50 years from now, or 40 years from now. So it's going to be an Indiana limestone project as well.
So is that becoming an easier conversation to have? The cost concerns are there up front, but just convincing them that, okay, but you're not going to have to replace it down the road.
Well, and now that we have, and of course I'm working directly with the facilities director out there, but and that's my role now. I mean, I worked in the field as an installer. I started on a trash crew, at 16 years old, but it really has become a pretty easy conversation if you get the right audience, because now that we have the physical data that we can put in front of them and explain to them that also you can sell to your contributors, to your donors and what have you, hey, we're also doing this in an environmentally conscious way, it's become a pretty easy sell.
And also with the timeline, right? Because when you work with natural stone, you have the raw material readily available, you have the fabrication facilities, and you can ramp up a lot of production. Well, when you're comparing it to man-made materials, lead times are to be considered because of all their molds and the dry temping, and then it has to cure. So using natural stone, like you were saying on this project, you had a limited time frame in order to do the fabrication and installation, which gives us an extra step up because we have the raw material readily available in the quarries, and we can feed the fabrication facilities much quicker than
And
doing
that-
it with man-made materials.
That was a big selling point because you had one manufacturer in Texas that was big enough to do this project, or thought they were big enough to do this project. And, I've always been a proponent of natural stone. I don't like cast stone because there's too many inherent things that can go wrong in the fabrication process. They cannot put the steel in it properly. They cannot, tamp it well enough. The moisture content can be off. They could maybe not cure it long enough, and it just doesn't look good on day one. And it definitely doesn't look as good 5 years later. But as far as one of the big selling points for us on this, time was a huge element because President Bush, 43, was moving in the 6th floor, and Harlan Crow was the owner with Crow Holdings, and Trammell Crow is one of the largest developers in the Southwest United States. And, he wasn't budging on time frame. And so we actually had 3D Stone working with 2 other fabricators controlling the whole, but they were able to produce in a lot shorter time period because the product was available, and that really did make a big difference.
Another thing to be aware of with EPDs is there's a life cycle that's defined within the report. And when we did our industry-wide EPDs, we used a life cycle of 75 years. So with cast stone, for example, it's not going to last 75 years. So when you talk about what's the environmental impact of this material, it's not just the environmental impact of that first installation, but if you're going to have to redo it in 50 years, then it doubles that impact, right? And that's one of the huge advantages of natural stone being such a durable and long-lasting material. We don't have those replacement impacts and those replacement costs. So it all works together. We've kind of gone through this already, but I just want to really drive this home. Why cast stone was originally considered, how you were able to convince them to switch to natural stone.
Yeah, it's, like I said, it was the beginning and the end. It was who was going in the building, and the architect, the design architect being out of London actually was a contributing factor to that as well, because his thought process was always natural. And he loved the idea. But, the numbers are a little bit skewed on this one because of market timing and the ability of the cast stone manufacturer to produce the job in the time required. But so, $175,000, it was a $13.5 million job. $175,000 is nothing. So it really was a non-contributing factor. It was just getting the right audience.
Mm-hmm. So did you consider other kinds of limestone? Indiana's kind of a traditional building material.
Well, we've built millions of square foot of Indiana limestone through the years, from D.C. to Ohio and Texas and all over the place, California. And it's just that part of the world, they have a lot bigger fabricators. If you were to try to do that project out of a Texas limestone material, it's not as durable, I don't think. The Indiana limestone's kind of been considered the nation's building stone for a long time. A lot of federal buildings are built out of it. And we had done so much work with it that for us, picking up the phone and talking to those guys and then getting those guys to work together to where we could pull multiple, fabricators together to produce the project. I don't know that there was anywhere else in the United States that I could get that done out of that material in that time frame.
And I like what you said, Rob, the other day. You were saying it's like a bookend. You started with the Indiana limestone at this specific project, and then you kind of bookended it using the same material as you did initially. I thought that was well said. When you can correct me, You're bookending
Yeah,
it, right?
and when I went in with the presentation to the owner, there was only 6 of us in the room, and we'd done other big projects out of Indiana limestone with the Trammell Crow companies, which was his father, and I was showing him this was variegated, this was buff, this building over here, and then I kind of went through the projects in Dallas that were Indiana limestone, the Meyerson Symphony Center, which is first project I worked on when I was 16 years old as a setter's helper, Indiana limestone, the Dallas Museum of Art's Indiana limestone, the Crescent. There's just an area right there there's a glut of it. So it's, he could go and see this over here and this over here and this over here. And then with his original building, it was 120 years old now, but at the time, it was 2017, so it was 113 years old. It was a statement for itself.
A statement piece. That's what
Yeah.
natural stone is all about. Budget. We talked a little bit about the budget on the last slide, but if we just really break it down, there's a lot of projects that eliminate natural stone from being considered in the early stages because there's this assumption that it's a lot more money. So let's just kind of break that down. This project specifically, the numbers are up there on the screen. The difference to switch to natural stone was only 2.5% of the budget. So is that common? Do you see that this project maybe had some advantages because of timing and availability?
Yeah, there are a few times when limestone is actually less expensive than cast stone. We did a big cathedral in downtown Houston that was about 120,000 square foot of wall, and there was a lot of flat wall panel. If you get a big flat wall panel, the cast stone guys can't keep up with the stone manufacturers. When you start getting into all the profile and detail that we have in this project, the cast stone guys, are generally going to be less expensive. The project that we just went to contract on last week at SMU is about a $3.7 million replacement. It's just taking the wainscot on the building off and the cast stone, throwing it away and replacing it with the Indiana limestone. Like I said, it's a $3.5 million job. It was about $150,000 more the initial cost to do the limestone, but with the relationship that I have with the ownership there, I'm like, look, we can do this one time. We'll never do it again. Mm-hmm. And 150,000, he's like, man, if it's 150,000, it's not even a conversation. Done. So, and we're hoping that there's a lot of projects on that campus, and we've built over 40 buildings there in our company's history that were limestone, and they had this transition from limestone to cast stone because the cast stone guys, blew smoke up their backsides for, lack of a better analogy, but that it was equal to, and it's not equal to because it just doesn't have the longevity that the natural stone does. But I'm hoping that this is the beginning of them beginning to remove that from the, on the newer projects as well. Not only replacing the older projects, but now, renewing coming out with specifications that actually list limestone in lieu of cast stone.
Yep, absolutely. I see a shift for sure. I'm involved in a lot of the, A&D type of trade shows like Greenbuild and ASLA, where they're, actively breaking down embodied carbon and asking these types of questions, and more awareness about stone. It's not where it needs to be at. I don't think it's getting the attention that it deserves as a natural, low embodied carbon, very durable material. But we're working, and we're seeing a lot of change in that respect.
And the owner that we're working with on this job, we're now building a private residence for him. He's a billionaire, so price isn't necessarily the most important thing to him. Mm-hmm. But the architect was talking about cast, and he's like, no, I want natural.
Yep.
I want it to have character. I don't want it to look the same. And, you know, the house that we're building for him is on 5,000 acres, and it would rival something that you'd see the royal family build out in, say, the Scottish countryside or something. But it's all granite and Indiana limestone.
Great. We love to hear those stories.
And it's over a $20 million contract for us for the stone and the masonry without the interior.
Yeah. All right, so that was a very detailed overview of the Freedom Place project. Let's bring it back to kind of where we started with the embodied carbon. So this specific project included 78,000 cubic feet of exterior cladding. And Indiana limestone came in at 200 metric tons of CO2 equivalent. If it would have been cast stone, it would have been 1,369 metric tons of CO2 equivalent. So we have an 85% reduction in embodied carbon by switching from cast stone to Indiana limestone. And what I see in the market right now is a lot of talk about how can we make concrete greener. Let's swap out some of the concrete for fly ash and make it a lower impact material. The same thing with other materials as well. They're trying to change their recipe a little bit, change their processes a little bit to make it a lower embodied carbon material. But what we don't hear enough of is let's just replace those high impact materials with lower impact materials. Eventually, we're going to get into a lot of conversations about using stone structurally. If we can replace concrete and steel from the structure of a building, it's astronomical the amount of embodied carbon that we can save. And just the climate impacts are really unbelievable. And so that's what I've been working really hard on this past year, and I'm not going to stop until I see some market improvement. But I think that we are getting there. We're getting into the right conversations. We're sitting at the right tables to convince the design schemes and the government to understand how replacing high impact materials with low impact materials is going to be a much more significant improvement in the long run than just making one single product a little bit greener.
And we don't talk about older buildings made of cast stone. We talk about historical buildings that are made of natural stone. So history is there to show us that the natural stone is there to stay. Cast stone, you don't hear about a monument that was made with a man-made material. You only hear about when they're made with natural materials.
All the beautiful landmark materials, landmark projects, buildings, natural stone. Okay, so we are going to get into a bit of Q&A. We do have a lot of resources within the Natural Stone Institute. Here's a few of them up on the screen. If you're looking to source regional materials, the Natural Stone Catalog is a new resource that we've introduced. You can sort based on sustainability documentation, based on location of the project, based on suitability of that particular stone for a certain type of an application. We have the Building Stone magazine, which we design and write for the design community to inspire them and educate them about using natural stone. We have the Natural Stone Resource Library. We've got lots and lots of documents, including our Natural Stone Sustainability Standard, including our EPDs. All of this is available for download through that library. Rob's an accredited commercial A and B contractor. This is a qualified labor credential. If you want to make sure that companies, that you want to use the highest quality installers for natural stone, you want to go straight to the accreditation credential.
Also accredited natural stone fabricator.
All three?
Yep.
Wow, Rob. I didn't
We
realize
have
that.
we have a smaller countertop, boutique countertop division.
You might be the only company. Do you know?
I don't know that there's another one in the state of Texas that does it.
Yeah, there's a few that have two of the credentials, but I didn't know that there was three. That's awesome. The sustainability standard, we didn't talk much about the sustainability standard, but this is a good thing, guys. The environmental product declarations really cover the environmental, a little bit of the ecological, but the Natural Stone Sustainability Standard is a more holistic credential for quarriers and producers. It covers environmental, it covers ecological, so it covers everything in the EPD, It also covers social justice. So there is quite a bit of growing concern in the market for ethical labor practices within the building materials supply chain. And the sustainability standard provides a third-party verification that those practices are not happening at the source of your materials. And then it also covers human health and safety. So what are we doing to protect the workers? What are we doing to make sure that people are safe that are entering and working and visiting our facilities? What questions do you have for myself or for our panelists? Yes, sir. Okay, so the question is, how much damage is manufacturing natural stone versus manufacturing artificial surfaces? Okay, so we covered this earlier in the presentation where we talked about where the raw materials are coming from. The natural stone industry does get a lot of criticism about land impacts. We're raping the land. We're taking a natural material out of the earth that's not rapidly renewing itself. However, all the other materials have some sort of stone in them as well. You know how cement is made. They're taking natural limestone, they're taking natural stone, and they're heating it and tumbling it at very high temperatures for a long time until it turns into a powder. They're starting with natural stone, starting at the same places that we are. So the argument about, we're the only ones taking these natural materials from the earth is just not valid. I hate to simplify it to that, but it's really true. We are all using natural materials, but we are being more responsible because we're not introducing other ingredients that are potentially harmful, and we don't have the emissions that the other manufacturing processes include. You guys have anything to add to that?
Oh, I was just going to say, I can remember it's been a few years ago now, standing in the Carrara Valley in Carrara, Italy, and I asked the question because I was just curious about the impact and, where they were. They've been quarrying that thing for several thousand years. Mm-hmm. And, how much material's left. Mm-hmm. And, the answer I got was we hadn't scratched the surface. Yeah. So, it doesn't seem like the overall impact is maybe as large as what some people would like to believe it is.
Mm-hmm. And you're absolutely right there.
And then most of the, with the quarriers, they've now got accreditations, cradle to grave accreditations, and they have they have plans for when they take the quarry and they finish using that quarry that they're going to now transfer that back to its natural use, rather they're creating parks or whatever.
Yep, the quarry reclamation plans.
Yep. Right.
We have a webinar on May 2nd, so it's next week. It's a live webinar through the Natural Stone Institute's platform. So go onto our website and register for this webinar. If you're not able to attend live, you'll get a recording of it after the webinar concludes the day after. But it's all about sustainable quarrying practices. What are the actual impacts of natural stone quarrying? What's the output of a natural stone quarry? How long does it generally produce stone, and how many square meters of building material is it producing in its lifetime? And then also, what are some of the examples? What happens to a quarry once it ceases operations? And there's some really, really cool examples of it turning into nature preserves and soccer complexes. And in Texas, the Six Flags is in a partial quarry.
Yes, it is.
Yeah,
One
it's a
down in
really
San
cool
Antonio.
project. Yeah. Any other questions? All right, well, thank you again so much for being here with us today. If you enjoyed the presentation, it is being recorded. Eventually, it'll be available on demand from the Coverings website, and we'll get it onto the Natural Stone University as well, so you can share it with other colleagues. But thank you to my panelists for being with me here today. It's been a really great topic to explore with you guys.
Yes,
Thank you.
Thanks.